Well, let's do a few more examples on Mr. Bruns, and we're going to talk about other ways that we can determine if triangles are congruent. So I've got a few quick examples. Here's our first situation. And we're trying to figure out, do we have some congruent triangles in here? I see 3 triangles total. I see the big triangle, but then inside you see the left triangle and the right triangle. So in this one picture, there's 3 triangles. Just intuitively looking at this, it sure seems like this one and that one might be congruent. We've got to really make sure that is the case here. Full disclaimer here, you can never trust my drawings. My drawings are not going to be drawn to scale. And we can only go by what the markings tell us. So the markings tell me these 2 sides, segment AB and segment BC are congruent, and segment AD and segment BC are congruent. So one thing that I often suggest is, let's take this picture and let's draw it out separately, maybe off to the side here, just to see if that helps me figure out if I have enough information to prove these triangles congruent. Because remember, everything that showed up on the list had 3 things in it. And right now I feel like I've only got 2 pieces of information, these sides and those sides. However, when I draw these triangles out separately, there is a 3rd hidden piece of information that has been sitting there, and it is this side right here. This was triangle ABD, and this is triangle BCD, but they both have this side BD in both their triangles. In fact, it's the same segment that they were joined up together with. And so we can say, sure enough, that, yeah, segment BD is congruent to itself. Segment BD is the same as segment BD. When we talked about, we just started introduction into proof writing, that when we wanted to explain why is that true, there's this property out there we call it the reflexive property of congruence, that the reflexive property told me something is congruent to itself. That's what we have here. So actually, yeah, BD is congruent to BD. I now have 3 pieces of information. I've got segment AB and BC are congruent, segment AD and DC are congruent, and BD is congruent to itself. There's 3 pieces of information. So if the question is, are these triangles congruent? We can say, yeah. So let's actually list them off. I think it is triangle ABD is congruent to triangle now. First triangle you list off, you can say that in any order you want, but then the second triangle has to match up with the order in which you chose to list off that the vertices of that first triangle. So angle A, what did angle A match up with in this triangle compared to the other triangle? Well, angle A was matching up with angle C. So we're going to put a C there. In this case, this angle B and that angle B are also going to correspond with each other. So that's a B, and then this angle D and that angle D. We can say triangle ABD is congruent to triangle CBD by side, side, side. Okay, we have 3 pairs of sides. That's our side, side, side. All right, moving on to our next example here. Again, it looks like we only have 2 pieces of information. It looks like segment EC and segment CE are congruent, and then AC and CD. Where's that hidden 3rd piece of information? And some of you may remember right here, anytime you have 2 lines that intersect each other, you are forming a couple of things that we call vertical angles. So this angle and that angle are congruent. In addition, this angle and that angle will also be congruent. So vertical doesn't necessarily mean up and down, just means in this case they're across from each other. So we have a congruent pair of angles here, this angle ACB and ECD. That's not a case of reflexive property because it's not the exact same angle, but it's 2 angles that have the same measure. They're across from each other. So we could say, oh yeah, hey, by the way, angle ACB is congruent to angle DCE. And the reason I know that is because vertical angles are congruent. So a little thing to remind ourselves of, we have angles that are across from each other, vertical angles are congruent. And now I have 3 pieces of information. Great, that's what I wanted. Are those 3 pieces of information in an order that fits on the list? And let's see, I've got a pair of sides. I've got 1 pair of angles. I got another pair of sides. We had side angle, which was on not the list, and we had side angle side that was on the list. And in this case, the angle is in between the 2 sides. So sure enough, we can say that these are going to be congruent by side angle side, we should probably list it off. This is going to be triangle. I can say ABC is congruent to triangle. Let's see. If I said ABC, the angle A in this triangle corresponds and matches up with the angle D down here. This angle B corresponds and matches up with that angle E, and then this angle C matches up with that angle C. So triangle ABC is congruent to triangle DEC. If you had said, you know, I wanted to list my first triangle as triangle BCA, that's okay. It just means that your second triangle would have been listed as ECD. Okay, both of these statements are perfectly correct. There are lots of different combinations in how you write that. Okay. All right, last example here. So I have, I forgot one little piece of information. We're going to say that this side is congruent to that side, but I also have these little arrows on here. And hopefully you remember that those arrows are indicating that these two lines are parallel to each other. And so this is a tricky little thing. It looks like there's almost no information in there, although if you remember from the previous example, we could say that these are vertical angles and those are congruent. That's absolutely correct. What you also might remember is that when lines are parallel and you have a line that cuts through those two parallel lines, what you get are a pair of alternate interior angles. When we see this Z pattern here show up, and that's what this is right here, from W to X to Z to Y, this Z pattern shows me, those two angles, those are congruent. They are alternate interior angles. And because the lines are parallel, they have to be congruent. So that's some hidden information that's in there. It doesn't seem like it's there initially, but once we see the lines are parallel, we can then state that, sure enough, these two angles will be congruent to each other. Similarly, I could have used this line WY as my transversal, and now I have a backwards Z pattern, but that works just as well. And that tells me that these two alternate interior angles are going to be congruent. This angle Y and that angle W are going to be congruent. And now I just have tons of information on there. I've got one pair of angles, two pairs of angles, and then these sides were parallel and they were congruent. That's what these little tick marks are telling me. So I have two pairs of angles and a side. So is this angle, angle, side, or angle, side, angle? There's two pairs of angles and one pair of sides. And in this case here, the side length is in between the two angles. So we're going to choose angle, side, angle, because the side is in between the two angles. So we would say triangle WXV is congruent to, let's see, WXV. It looks like W matches up with Y, and X matches up with Z, and V is matching up with V, and all of that is true because of angle, side, angle. All right, so there's three sample problems for you, and you can rewatch this video if you need to. You've got plenty of practice problems in your parent guide, and you've got a few problems to work on for your homework. Okay, so if you have any questions, certainly send us an email, let us know, and we'll help you out with any of this stuff.